All right, everybody, welcome. In the interest of starting on time and under threat of pain and death from the conference organizer, we are going to proceed. We're going to start right now. I know we just finished supper or lunch, so some people might be straggling in afterwards, but we have to start on time. And we'll try to finish up about 5 minutes early so we have a brief opportunity for everybody to ask some questions and answers if they want. So welcome, everybody. I hope you're certainly enjoying the conference as much as I am. This session titled Brain-Related Auditory and Visual Impairment, An Approach to a Complex Relationship, is brought to you by two speakers. The first, Jude Nicholas, who will be speaking first. Dr. Jude Nicholas is a certified clinical neuropsychologist and a researcher employed at, I hope I'm saying this right, StatPed, Center for Deafblindness, and at Haukeland University Hospital in Bergen, Norway. Dr. Nicholas has some 25 years of clinical and research experience working with children and adults with different sensory loss. He has a long-standing interest in toxic conditions, genetic syndromes, and neurological conditions involving sensory impairments and cognitive functions. He is author of several articles and book chapters on these topics. His current research investigates the neuropsychological functions of brain-related visual and auditory impairment and the pragmatic understanding of how the tactile systems functions, particularly in persons with deafblindness. I'm also going to introduce our next speaker so I don't have to interrupt in between. We will be joined after Jude by John Ravenscroft over here. Chair of the Childhood Visual Impairment, is a psychologist, educationalist, and uses philosophy into his work. Professor Ravenscroft is director of the Scottish Sensory Centre, which provides career-long professional development for teachers of children with sensory impairment. He is based at the Moray House School of Education and Sport, University of Edinburgh, and he is also the current editor-in-chief of the British Journal of Visual Impairment. He is the president of the International Council for Educators of Children with Visual Impairments in Europe and lectures on cerebral visual impairment, inclusive education, as well as research methods. He is known for his work on cerebral visual impairment, and his conversations about CVI have been viewed thousands of times on YouTube. So he's a YouTube star. Professor Ravenscroft is often found on Twitter and welcomes any discussion about the nature of representation. So without further ado, Jude Nicholas.
Thank you. Thank you, Alan. It was a great honor to be introduced. Well, the topic for today, as you all know, is about the brain-related auditory and visual impairment, which is, I'll be using the word BAVI. So when people ask me what's your topic is going to be about, I said it's a four-letter word, and that's BAVI. And we want to understand it in a complex way. It's, as I say, an approach to complex relationship. And that's also my relationship with John Ravenscroft. We have been very complex, but we have managed to come further. So let's start. We have an overview. Hopefully we'll have more times for questions and discussions at the end. We want to put across the concept of this condition, and in my earlier presentation today, I gave also a talk on the behavioral characteristics, and I will maybe say more about the neural networks which we know exist regarding this both the condition and the processing units, and what about BAVI in other conditions. So we'll bring it back to deafblindness, and then mostly John will continue further. So that's just an outline or overview of our presentation. Right. So how do we like to conceptualize this condition? So as I mentioned, BAVI may refer to a combined auditory and visual impairment caused by disease, damage or maldevelopment to the brain's auditory and visual pathways, and processing center. So it's brain-related compared to the peripheral system when you're talking about the eye and the ear. BAVI can affect both visual and auditory input, and processing and may share behavioral characteristics with both auditory processing disorder, which is called APD, and CVI, which is the cerebral visual impairment. Impaired processing of both auditory and visual information creates a condition that is much more complex than the addition of two processing impairments. So going back to the definition of deafblindness, as we know, visual and hearing impairment combined will lead to a more complex but also a unique disorder or deficit. So this is the same way we are trying to conceptualize the condition of BAVI. This is again, I did it earlier today, just to put that across. We could talk about CVI, we could talk about APD as impairments affecting the visual pathways, CVI, auditory pathways, the APD. And we could see a lot of similarities if we break them down into those processing functions in a way. And you could see listening problems on one side, and then you have on the auditory side, we also have a figure ground discrimination problem regarding the auditory modality. Sound location would be a problem. Again, the source of sound, it's not only the ears, it's the brain which is involved in localizing complex sounds. And then you have the same way rapidly changing auditory signals, which will impair temporal, which is time related, like sound is very much sound related. And finally, you have cognitive functions which might be affected, like the auditory working memory, and then fatigue, which might be related to it. The same way we could also organize or categorize the CVI into the same manner. So you could already see a lot of similarity, which there's a difference, like, of course, when it comes to the visual information processing, there will be understanding vision will be a problem, understanding scenes in crowded environment will be a problem, facial expressions, route finding, and depth perception and such will also be different because it's a visual impairment compared to the auditory. But it shares similar perceptual and maybe even cognitive aspects related to that. And as you can see, auditory working memory is affected in APD, and visual working memory might be affected in CVI. So again, we are seeing there are certain behavioral characteristics which are similar but related to their domains or visual or auditory domains. So why is this? A complex picture, I don't want to go into too much details, but then again, just to see how the visual system works and the auditory system works. It's again how information is received through the ears, through the auditory system, targeting different areas in the brain. Most of you all are familiar with the visual system, where we know there's a where and what system, and it also exists for the auditory or in the auditory system. There is a system where sound, the where is processed and the what sound is processed. So it's not only in the ears, but it's also the brain processing. And then, of course, you have the differences, like mostly when it comes to the APD, CAPD, which is the central auditory processing. We know the corpus callosum, that's the structure which connects the left brain with the right brain, is affected, because then we know this is much related to auditory processing in processing disorders. And many studies are also related to understanding APD in the elderly, right? So it's again, we know it's these areas are all already affected when we get older. And then you have the most recently discovered thing is also not understanding just the auditory system, but it seems the cerebellum, which is the structure of the brain, which we normally connect it to motor functions, is very much related to auditory processing, right? Because it's the similarity between a motor function and auditory function. It's the the time, the temporal effect of it, right? Because if you don't coordinate your motor actions, you could see deficits the same way if the brain doesn't organize time of sound in a proper manner. Processing deficits will occur. So the cerebral system will be involved. When it comes to the visual brain, as it says, it's also, we have the when and what areas and more complex things in the visual brain, right? Just to see what we call how information flows. So visual flow seems that the brain has a way to not see things as individual graphics or images, but it's a flow which the brain processes. So all in all, yes, it's a balance, as you say, between a network. There's an integration between these two systems, but they're also segregated. That means they could they work independently too, but it's also very strongly connected, right? So just to put that across, CVI would be more addressed by John. Just to put this across, new research of understanding APD, right, in the brain. It's not just information coming in and or sound coming in and being processed. Some might know we have an active system in the brain, which is called the executive control network. And we have a default mode, that is like when it's about where the brain is active when it's a rest state, right? And so this is what we call the default mode network. And what seems with auditory processing disorder, it's not just one system is affected, but it's the imbalance between the rest system of the brain and the active system of the brain, right? So this information, again, we will need to think, what does it mean? How could we intervene, right? It's from 2023, a month ago, which was published. So we are getting more information about it. We need to understand. Again, it could help us regarding interventions too. I think, John, the next one is yours.
So, I've got my timer here with me.
Oh.
So, my colleague, Lofty Meribet, is presenting the very same slide at the Vision Conference, and I thought it would be cool to present the same slide at the same time on CVI. So here we have an image of 4 MRI scans with controls, and there's 2 at the top, 2 at the bottom, 2 at the top of controls, and it's looking at the lower visual field and looking at the optic radiations, the information that goes from the eye to the back of the occipital lobe. And in the controls, they're all lit up, and there's lots and lots and lots and lots and lots of them. And in the CVI, the optic radiations are depleted. So the information that's going to the occipital lobe, as well as damage within, can also be less as well. And that's a child with CVI. And again, Lofty showing this one. So in homage to my colleague, here's an image of 2 brains, and the image are going to be spinning around. And again, what we're going to see is the neural firings that you see in vision. With a little bit of luck, here we go, they're spinning around. And one on the left is control, the one on the right is typically a person with CVI. This is a computer-generated image. And as you can see there, the key visual pathways are so much depleted in a child and with a person with CVI. And this is the information that is then put within this network that Jude was talking about today. So I'm not going to go into and explaining a lot more detail about CVI. I could talk about that for 1,000 hours, but I'm not going to. And I'm going to hand back to my trusted colleague. Yes. And we're at 10 minutes in.
Good. Thank you. Yeah, this is the complex relationship we have with him. So. Okay, so going back to the condition of BAVI, which is like, so we are, of course, we need to understand the condition, but also in regarding deafblindness, which we will touch later on. But does it exist in other conditions or any other clinical conditions? So how do we describe all the diagnostic features related to that? So here are 2 conditions which are described in the literature. The first one is, again, in service members and veterans, where most of the combat veterans are coming back after their tour in, say, Afghanistan. And what they have been seeing is like they come back and mostly they complain about visual and auditory difficulties. Normal, when they do their test, the examinations, vision is normal, or auditory, or the hearing is normal. But then again, one has gone further to see whether could this be related to a processing disorder, right? Because they have been exposed to something, especially these veterans, into combat injuries. So now we are talking about comorbidities. That means like they are co-occurring conditions. Of course, there's TBI. If they were involved in a combat incident, their brain must have been, it's a concussion or maybe more. So we need to also address that the brain has been affected. And they come back with, of course, PTSD, which is a post-traumatic stress disorder, and more brain-related, or the BAVI condition, right? So given the next slide may give a better understanding, because if persons who come back from a combat and be treated for PTSD, and they complain about their communication disorder or visual, in a PTSD treatment, those issues are never addressed, right? That's one condition. The other condition is where I see these patients in my neurological ward in Bergen. These are professional divers who have what we call the decompression disease, and that's like they might have a high pressure exposure, and this may create what we call a barotrauma, right? And then again, this has a high risk of affecting brain structures regarding visual and auditory processing. So these are the same type of, as you could see, the similarities between that group of veterans and professional divers, and we are working on trying to understand BAVI in the professional divers, and we see that because barotrauma will affect, your eyes and ears, but when we measure their hearing and vision, they are so minimum, but their processing is a problem, right? So there are conditions which recently we could say there are brain-related auditory visual impairment. Okay, so just very quickly, yes, there's a list of we at our clinic do. Just to put that across, we do the normal hearing visual test, and we do the test related to CVI, APD, a lot of neurological, neuropsychological testing in all modalities, right? We want to test the person's functions in tactile, visual, and auditory, right? To put that across, what is more impaired in this person. And functional vision, informant report measures regarding communication, cognition, and fatigue. And then a diagnosis is given using both the objective and the subjective measures. And of course, as I said, the differential diagnosis is so important, right? If this person has a PTSD, in addition, we need to write a report and say, this person also has a visual auditory impairment, right? Brain related. So across the lifespan, we could see children with CVI, they could overlap with autistic spectrum disorder, and for APD, it's ADHD, right? So how are we going to bring those conditions into this picture, right? So again, just to put it across, we are trying to address this with the knowledge we have, and that's what we are sharing with you all today. Okay, so it's back to John.
It's like Tom and Jerry. Yeah. All right, good. Yeah, as grown adults, you think we would have practiced this, but, So, okay, so BAVI, I call it BAVI actually. It's just like, I'm from the north of England, so we shorten our vowels. So it was interesting, there's a couple of posters, and some of you might have done the poster looking at the prevalence.
Oops, sorry.
Oh, thank you very much, looking at the prevalence. And due to the difficulties in assessment, due to the difficulties in looking at people and children with BAVI, look, we really don't know. We just don't know what that percentage is. There's a really good talk that we went to here, looking at from a school in just along the road, I believe, in Ottawa, and the percentages were really, really high of those confirmed and suspected, both having what we would call a BAVI as well. Like the majority, it seemed, of their children. Are they here, the speakers? There they are. Yes, there they are. So the majority seems to be within this group, but we don't really know. And it's really important that we find out. And it's really important that we do know that there are people with this, with BAVI, as we would say. So very few data sets, and it's limited knowledge. It requires professionals to cross over skills and a whole range of other stuff. And I'm going to argue from philosophy. Some of you may have seen variants of this talk before, but I think it's important and it's relevant for deafblindness, it's relevant for blindness, for CVI. But I'm arguing it's why it's important to understand and know, and why you should look at the populations of people you're working with. And I'm going to argue this case from philosophy of perception. So you should all study philosophy, right? That's my big main thing, to understand the work that you do. So I'm going to argue the case as to why you need to understand and identify and work with, in a multidisciplinary group, identify children that have BAVI. So, but before I go into that, just very quickly, we need to just have a quick concept mapping of, well, I'll just look at my phone, tells me the time, I'm okay, pre-attentive and attentive. So there's a difference between in terms of perception, if you're pre-attentive, so you might just be aware of some salient features of stimuli that gives you to look at it, whether that stimuli is sound or vision or tactile, that's pre-attentive, and that conscious awareness, that conscious engagement is actually the attentiveness. So I'm going to talk about attentiveness, I'm not going to talk about pre-attention. That's a whole different talk, and that's a more of a neurological talk there, as Lotfi would describe it. So, perception. It's really important to understand what a person perceives, right? That's probably what our job is about. What are the people that we're working with, what are they perceiving, and how do they perceive, right? So how do things appear to us? Or as a person with BAVI, I see the contrast isn't that good on this. It looks great on the screen at home, but it looks terrible here, so apologize for that. What is it to perceive an object? So I'm testing out your perception already. How does perception enable us to think about it for people with BAVI? And is there a hierarchy of perception? That's quite an interesting topic. Is there a hierarchy of perception? Do we see and perceive things differently? And so one way of looking at this is to think about a theory in philosophy called the representational view of perception, and that's what I'm going to present. So what's really, really important to get at, and I think our first speaker, the keynote, the preliminary this morning. So the world, as you know, isn't out there. The world is created in our minds, right? That is absolutely a given fact, right? We perceive the world within our heads, right? There is no doubt about that, right? And that is, this world is how you experience it, right? And so my world is very different to Jude's world. It's different to your world, it's different to my world, it's different to a child's world, it's different to the world. So what is in my head, how I represent the world, is different to how Jude represents the world. And there's lots of reasons for that. And so we have to understand that as a basic premise. So when we're working with children with deafblindness or with BAVI, is that we have to understand then what is the limits of that representation? How is that representation different to the diver or different to a child? We have to get that. How is the world represented by people with BAVI and who don't? So, One way of arguing this is this. So on this slide, I have two images. One is an image of a tomato, and one is an image of a lemon. Good, good, good. So there's a tomato and a lemon. What color is the tomato? Good. And what color is the lemon? Good, good, good. So your perceptual processes are working there, right? So that's quite interesting. So a lot of people, I'm not saying you do, because you're wrong, all right? You're all idiots if you think this. But if it's like this. So a lot of people think that the tomato is red or the lemon is yellow because that's the properties that the lemon has. That's the property that the tomato has. It physically exists in the world. Right? So the tomato is red because the tomato is red. Tomato is round because it's physically round. Right? And so most people think this is how perception works, that it's actually physically out there in the real world. Right? So this is what's called the naive theory of perception. Right? Red tomatoes, and these are what's called the qualia argument, they already exist in the world. Right? So when Jude sees a tomato and I see a tomato, we see exactly the same thing, right? Because that's what the experience of the tomato has, right? So the properties in the world is what we perceive. This is the wrong theory of perception. And we know this is wrong, right? We know this wrong by lots of ways. The problem of this theory is you see is what you get. So that's a chair, it's got that particular shape, and it's that shape because it's that chair, and that's what we get that. Tomato is red because the tomato is red. However, it's wrong on many, many reasons, and one quick reason why it's wrong is the problem of color. All right? Color, as we know, it's just different light frequencies that enters into the eyes and into the brain, and we then process it in our systems for it to be yellow. Now, you all, fortunately, process it the same way, and you all cognitively perceive that as being yellow or red. But actually, color doesn't exist in the world, right? We process color in our brains. Yellow is not a thing that exists in the outside world. We process it in our heads, right? Same as red, same as all these things, right? And we know this, right? So what is color? So humans, as we know, are trichorates. Dogs are di. Some animals have more cones and so forth. So color is not part of the world. Color is how we see it. We perceive color. It doesn't actually exist. So there's lots and lots and lots of examples like this. So you can imagine a case where I see a tomato as being red, just like the rest of you do, but you can easily see an alien or a person or anyone else who sees it red something else. So who's right? Do I see it as red, or does that person who sees it red plus? Are they right? So who is right in this debate when we see what color is a tomato? And so we're starting to think about what is it that that person sees. So we know that color and perception is all in their head because we've got lots and lots of visual illusions. And illusions are a great way of demonstrating perceptions. So two of my favorite ones are the checkerboard, the A and the B. So I have an image of a checkerboard and they have A and B. A is on a white square and B is on a black square. Actually, all the squares are exactly the same color. Right? There is no difference in the color of the squares. What we've done is a little bit of light that fools your brain. But in the real world, all the squares are exactly the same color. Right? There is no difference in the colors of the squares. Your perceptual internal representation of the world is showing that there is differences. You're being fooled by your perceptual processes all the time. The one on the right is either, this is a good image because it's real world, is either a raven, a big black bird, or a rabbit. A raven or a rabbit. Do you see the raven and the rabbit? Yeah. But there's no such thing as rabbit raven. That doesn't exist in the world. I'll just go and buy a rabbit raven or a raven rabbit, right? That doesn't exist. So raven rabbits, you're quite happy to accept a raven rabbit, right? but they don't exist, all right? That's your perceptual processes going to work. So what is out in the real world is not how you perceive the world. And this is really important when working with people with BAVI. You have to really, really get at what is it that they're perceiving. And if you think they're perceiving the same thing that you're perceiving, then lordy, you're go and become a mechanic or something. Go and do something else, all right? So the way I do it, the way I like to see the world is called the representational view. And the representational view of perception is the one that I generally would go to, it's the one that I hold to. So it's how the person experientially represents the world. It's part of their experience and how they then perceive the world, whether that's through auditory, vision, or tactile. It's their experiential representation of the world that does it. It's what your system tells you about the world. Now, if that system is damaged in any way, it's still going to tell you what that world represents. Right? So that's what we have to get at. We have to understand exactly what these systems is telling you about the world. It doesn't create an image in our head. It's not like thinking about an image. So I've got an image of a red tomato in my head. It causes us to see how things are in the world. That some objects exist the way they exist based on the representational image. So representation is the things that they might be. It's how they might be in your head, in my head, and how it might be in Jude's head, although there's nothing there, right? So how it might be, or the way there is. There is no mental object. And what I'm trying to get at is, it's basically the essence of this image, which is Van Gogh's paintings of sunflowers. It's the essence of painting is not to be found in the patterns of the marks, the patterns of the paint on the canvas. It's what these marks represent. So when you are thinking of assessment, when you're working with children with deafblindness, or is this a child with BAVI, thinking is, what are they representing? What are they representing the world? Are we able at a position to be able to distinguish between A and B? Blindness, deafness, BAVI, and any other. We have to be able to understand that representation. So, is there a hierarchy? Now, this is the work of Zander, used to be at Quintalis, Royal Dutch, Bartimaeus. I'm looking at my friend at the back, Frank, who's going to give me a thumbs up. And Zander talks about being able to work out the cognitive axis, and this is the cognitive hierarchy of representation. So are we then able to work out about those higher level of properties of anger, sadness, surprise, words, focus, locus, and then the lower properties such as color, shape, distance, motion, maps. Maps can be argued for intermediate, I would say, with that. Global attention, specific attention, and mediating the choice as well. So we need to be able in our assessments to work out these cognitive axes. What is enabling us to have these representations in our head for a child with BAVI? So we need to change of thinking. And I really think it's important to see how we can change that thinking. So my mentor, Professor Dutton, improvement of vision in children with CVI is based on perceptual learning. That's exactly what it is. That all materials falls within each child's functional vision. I think we should change that to improvement in children with BAVI is mainly based on perceptual learning, ensuring that all materials fall in the child's representational view of the world. How does that child have that representational view of the world? That's what we do. Because we do not understand how a child with BAVI experimentally represents the world, then we do not understand how the child perceives. And if you can't do that, then intervention is a hit or miss affair. Might as well just toss the coin up and see what gives. You have to understand what the child is representing in the world. So, getting back to the beginning of this talk, I was going to say Lofty, but Jude talked about networks. And this is exactly right. It is all about networks. And seeing the brain as the single identity, or for me in CVI, when people talk about dorsal or ventral streams, it's not a stream, it's a network. So please don't use the word stream anymore, use the word network, because a stream is usually unidirectional, goes that way to that way. That's not how the brain functions. Right? So that's quite important. So it is a network. So Lotfi and I really think that it is indeed representing the whole entire brain. And so therefore, if you think of the brain as a network, complicated networks, there are networks within networks. So the ventral network has networks within it. The dorsal network has networks within it, but they all talk to each other. So the ventral network will draw down information from the dorsal network and vice versa. They are communicating with each other all the time. So if you think about this brain-wide system, network system, and understanding which networks talk to each other, it's no surprise that the majority of the children in your school just across the bridge, if it's across the bridge, I'm using that as an analogy, has BAVI, right? I'm not surprised by that, I think, to be honest. So, using a multidisciplinary approach and considering the whole brain can lead to greater understanding of how brain connectivity following injury or maldevelopment explains the complex profile of CVI and deafblindness in BAVI. That's what we have to really consider, is that whole brain approach there, and not our simplistic understanding of dorsal ventral systems, auditory systems that go back from our occipital lobe and onwards. We need to discover these associations between perception, behavior, and underlying brain structure, which is the current work that we're doing now. And once we do that, we should be able to then to really accurately, and it's interesting that you're doing it and you have that suspected children with CVI and BAVI to develop and adopt. It informs clinicians and within our education problems. So, am I on time, Mr. Time Man? Oh, 5 minutes. Hey, look at that. Who thought we would have practiced? Yeah. All right. So, I'll slow down a bit then, all right? So, we need to understand the new term BAVI. I think it's a term that we want to get to use, because I think it is quite an important term, because I think there's just no surprise to me. I think there's going to be a lot. I only work with children, I'm afraid. So I think there's going to be a lot of children with BAVI. We need to really understand what a child sees, and that it's externally directed. It's in to out, not out to in. Right? That's really the biggest message I can get away today. What we see is inside out. Right? There is no such thing as color. We process color in our heads. It's scary. Once you think about this, then you start thinking, oh my goodness me, right? We need to understand what the child experientially represents the world. How does that child experientially represents what properties the child has and what cognitive access they have to understand that hierarchy. And understanding then the complexities of BAVI enables both development in both disabilities as well, I think there. So, that's some of the questions in case nobody wanted to ask questions. We thought we'd ask our own questions. So if you've got any answers to our questions, we can do that. Great. Thank you very much, Jude and I.
Okay, thank you, John and Jude. I don't know if we have a lot of times for questions. This is obviously a complex subject matter, and really I think we could dedicate a whole conference to it. My wife, to Jude's point, has always said I have an imbalanced brain, but this is not what I was thinking she was talking about. So I guess, does anybody have a question? I know we've only got about 3 minutes, and I'm sure they'll be available for the rest of the conference if you want to follow up. So maybe that's the best route to go, just to keep us on time. But on behalf of the conference, I just want to thank you both, and we do have a little something for you. Well, first of all, before we leave, hands up who first saw a bunny. Everybody saw the crow?
Yeah, it's the white tip. Everything else is black with a white tip.
You saw the crow first?
Everybody here saw the crow first. Yeah? Until we heard the word bunny, and then all we could see was a bunny, right? Okay, so thank you very much for coming. I didn't put my glasses on, they're on my chest. Jude. Yes, thank you very much. And John. Thank you very much.